Thank you. All right, we'll give one more minute for people virtual to join. I guess while we're waiting, I think it'd be great to go around the room, mention briefly what company you come from and why this breakout session is of interest to you. So perhaps we can start in this corner.
So hey, I manage the technical partnerships with Google, some of the strategic partners, and I have a team of research engineers. We are working closely with Google, trying to understand how to fit these different forms of lowering. So this session is super helpful.
Yeah, so I'm from Google ODML team, and we will have a breakout session on what we've been up to for the last few bit. And I guess that's pretty much why I'm here with the StableHLO breakout room as well.
Should I mention where I come from?
Not
Not. Oh yeah, I'm from NVIDIA.
Cool, great.
I'm Zach from the journey. I'm here to learn more about HLO so that I can write better jokes.
All right.
Pushkar from AWS Labs. So I primarily do front-end stuff these days, graph level optimization and so on and so forth. And we're trying to transition from TensorFlow to OpenXL.
Cool.
Right.
Would you like to introduce yourself, say where you're from, why this is of interest?
I'm a software engineer from ByteDance.
I'm from Intel. My name is AG Ramesh. I mainly work on the CPU side of XLA, but my colleagues who work on the GPU are not here, couldn't attend. So I'm trying to sit here to understand what's happening in PjRt and get a feel for what's going to change on their behalf.
Sounds good. We'll keep going on the outside of the room.
Hey everyone, my name is Ankit. I come from Meta. I work on applied AI at PyTorch. I guess why I'm here is I heard about, I haven't really used XLA before, so I'm just here to learn something new.
Great.
Hi, I'm Mark Gotcho from Samba Nova in the compiler team. Past life, work on TPU hardware team. So yeah, just here to look at StableHLO, PjRt, and see how we might be able to integrate with our own Samba Flow stack.
I'm Joshua. I'm also from Samba Nova. Same reason.
I'm Reed. I'm also from Samba Nova. So I also am here for the same reasons.
Hi, I'm Richard. I'm not from Samba Nova. I'm from ASCII. I work on Ray, which is distributed Python stuff, and we've been working very closely with the TPU team. And so PjRt is of interest to us because that might be an operation, like a sort of direction that we can take to do some tighter integration of it.
Hi, I'm Ganyan. I'm from the StableHLO team at Google, and I'm just here to take notes for you guys.
I'm Saram Singh. I work at a company called Grok that makes chips for machine learning. Our compiler natively takes in Onyx, but we want to see if we can use StableHLO to connect to things like JAX and TensorFlow. And I've put just a previous life at Google doing TPU chips and XLA.
Cool. Very nice.
Oh, hi. This is Sean. I'm from Google. So I'm the TL of PjRt.
Cool. Great. So I'm Kevin. I'm from the StableHLO team. And just a first word on format. A lot of the PjRt representatives are also JAX representatives. So they are doing the first half at the JAX breakout session. And then halfway through, we will shift the focus to PjRt. So to get started, we will be mostly focusing on StableHLO. Just to see if I can put this slide here. Okay, just to make sure we're all on a level playing field and all talking about the same exact thing. Brief coverage of what is StableHLO. So StableHLO is a ML offset. It's an MLIR dialect, and it is intended to be used as a portability layer between frameworks like TensorFlow, JAX, PyTorch, and compiler backends, either OpenXLA or other MLIR projects. You can write converters from StableHLO to other dialects, as well as TensorFlow serving. There was a PyTorch XLA presentation earlier today, which got into how you can now make your PyTorch program, package it in a saved model, and serve it on a TensorFlow serving server. So why is this important? StableHLO needs to represent all the things that frameworks want to be able to represent. And it also needs to be granular enough where it's useful for compiler optimizations. So on this next slide, I'll talk a little bit about what we've done in 2023 and what we're planning to do. But at any point, feel free to come in with questions or thoughts or comments, or just let us know what's important to you. I think the main goal of this breakout session is to make sure that our goals are aligned with community goals.
I have a question already.
Yes.
So you mentioned it as a portability layer, so you don't see it as a MLR dialect in itself? That
So it is an MLIR dialect, in implementation. But portability layer in the sense that it is, we use MLIR bytecode format for serialization. So in that we have a self-contained program with forward and backward compatibility guarantees. So in production, we have use cases where the producer of StableHLO is on a slightly different version than the consumer. And that's sort of where the portability comes into play. We're able to handle producer and consumer using different versions of LLVM, MLIR, plenty of other things.
but it can be a single dialect that you can write a compiler transforms in as well.
Yep, exactly.
So you said it needs to be granular enough that the compiler can optimize it. What was needs to be coarse? What was the other option? It needs to be coarse enough that.
It needs to be generic enough where frameworks can target it. Because I mean, the semantics of an operation in TF are not identical to PyTorch, but we need to be able to represent both in some way, but also not in a way that is impossible for compilers to optimize.
Nice.
Yes. Okay, so a recap of 2023. The way that this is sectioned off is things on the top are things that the core StableHLO team has been working on and been focused on, and on the bottom are contributions from other teams within Google, other teams from outside of Google, but these things on the bottom were all contributions that came from not the core StableHLO team. But as of Q1, we've had compatibility guarantees. They're currently 6 months of 6 months of backward compatibility and 1 month of forward compatibility. And what that means is that you can have producers and consumers on different versions, and we have production use cases where you introduce a new op and we're able to handle it out of the box, or we're able to tell you this thing's not going to be able to run on your target device for this reason. Here's what you can do to change it. We have backward and forward compatibility testing. The next work stream is this reference implementation, which is something that Gunyan was a very large contributor to. But we have a full specification of the 97 ops in StableHLO, and we also have a reference interpreter that's capable of running, I think we're at 91 of those ops. And the remaining ones are things like random bit generator or things which might have more implementation defined behavior. On the documentation work stream, we've been releasing, I guess, just trying to cover all of our public APIs. The spec plays a large role of documentation, but so does things like denoting that we use MLIR bytecode format, or talking about how to use the reference interpreter, and things of that nature. And then these two ongoing work streams, which are things that we are considering very high priority to the community, and feel free to tell us if you feel differently, are spec compliance. So we have this great and beautiful spec. It tells you exactly how these ops should behave. Let's make sure that if something diverges from the spec, you get a clean error message. And last is front-end contract, which just means that everything in the offset is well defined. Currently, we have this spec, as I've been mentioning, but currently it only covers statically shaped programs, not necessarily dynamism. Or it covers quantization for certain ops, but not all ops. We expect quantization based on community requests, and so that could be an ongoing thing. And then the last one is extensibility. There's been use cases from other companies and within Google for a way of capturing higher level abstractions. So StableHLO is very low level offset, and there's a lot of constructs that are basically sugar on top of StableHLO. and plenty of backends want to be able to pick off these patterns at a higher level than just StableHLO. So we're working on an extensibility mechanism for doing those things. And I think that summarizes the three main things we consider to be high priority on the core team, namely quantization, dynamism, and extensibility. I guess if there's any thoughts on that or additional features that are not in the StableHLO offset that are important to any of you. Great. So I guess second half, I'll talk about some of the developments that have come from outside of our StableHLO team. Jack's native serialization was a very big one. For those that don't know, Jax for serving translated from Jax to TensorFlow and then packaged it in a saved model and then sent it off for serving. This worked for a while, but on the other side of serving, it would compile back to HLO. So it's pretty much Jax, which maps onto HLO, would get converted to TensorFlow, so it could get converted back to HLO so that we could compile it. And there was this expectation that the HLO would be the same before and after that conversion to and from TensorFlow. And we said, hey, the only reason we're doing this conversion to TensorFlow is because saved models are stable. Well, now introduced StableHLO has the compatibility guarantees that we need. Why not just use that instead and try to remove TensorFlow from the picture as much as possible? And so that, as of maybe a month or two ago, is now the default Jax serving mechanism. If anybody uses Jax and uses Jax to TF, the save model that comes out of it actually is now just StableHLO packaged in a save model. That worked great for ensuring XLA compilation was one-to-one without having to round trip through TensorFlow. But we also saw some unexpected benefits of, since we use MLIR bytecode format for packaging StableHLO programs, they were incredibly smaller binary sizes, like on the order of, we thought it was a bug at first, and it turns out that it was just actually a far more efficient means of representing large constants. On the PyTorch side, no major new information to talk about here. There was that presentation that was the second one of the day where Han talked about PyTorch's StableHLO APIs. We've been doing a whole lot of work with the PyTorch XLA team to make sure that all these nice benefits of StableHLO can be leveraged from PyTorch. So as of now, there are several APIs for going from PyTorch program to StableHLO program, and even from there to go to a save model program if you wanted to serve it that way, or if you want to consume StableHLO a different way, you can now do that for your PyTorch programs. There's still ongoing work for these APIs. We're in the early phases of exploring exporting dynamism or quantization or things of that nature. Those were briefly touched upon earlier today. But that's all early, but on the roadmap. I had mentioned quantization, dynamism, extensibility as our three main areas of focus for the remainder of Q4. Those are all public RFCs. I'll find a way to make this presentation public. I'm not sure where we'll be posting artifacts, but all of these underlined things are links to public documentation or public RFCs. We use OpenXLA Discuss. If any of you are not already joined to that, that is where all of our announcements and RFCs are posted to. So if you want to stay up to date, OpenXLA Discuss. And then there's sparsity. I'm actually curious if any teams in here have interest in sparsity.
We're definitely interested in sparsity at StableHLO. We haven't looked into anything with it on the StableHLO side yet, but that's something we're definitely going to be looking into in the future.
Is it specifically to for sparsity or just even more general than that?
More general.
Okay.
Yeah.
Cool.
General sparsity quantization stuff right now.
Okay.
Yep.
So yeah, sparsity is one of those things where we've been uncertain of its priority, and all of the use cases we've been aware of to date are kind of satisfied by 2-4 structure sparsity. So it's good to hear that there are even more general.
Yeah, I think our interest is a little coarser than that. But not like fully coarse grain at the level of like completely different models, right? So we're not sure where we stand, but generally interested in that stream.
Cool. The 2-4 structured sparsity RFC is ongoing, and Art is the author of that, who is Mr. Sparsity. So it'd be good to leave feedback on that. He'll be very happy to hear that there is broader use cases for more than just 2-4 structured sparsity as well. Then TF Lite, each one here, would you want to talk a little bit about, maybe a brief intro for what's going on the TF Lite RFCs?
Yeah, so for on-device use cases of the StableHLO, we have a higher level requirement on compatibility. As such, we have committed, or we have sent the new compatibility extension RFC into the StableHLO group, and we'll do the next step at this point.
Yep. That's an ongoing RFC. There's some open feedback. We just need to address it and then press forward. But main point there is community RFC for increasing compatibility to 3 years forward and backward compatibility. So if there are use cases for broader compatibility, we are very open to extending our guarantees. The infrastructure is in place. We're just trying to keep our maintenance overhead tied to existing use cases.
Honestly, I think most likely we'll have to extend that 3 years down the road.
Good to hear. And 2 RFCs have come through for our reference interpreter. As I mentioned, it's very well fleshed out at this point. The probe op was one that was introduced by a team that wanted to test the numeric accuracy of their compiler against the reference implementation. So what probe op is you can insert this probe operation in your MLIR program wherever you want it, and it will save the intermediate tensor values of the program to a NumPy serialization format. And afterwards, you can do the same thing for your compiler and compare numerical differences using NumPy. Or you could also do something that it's a flexible machinery, but it's able to extract tensor values at any point of the pipeline. And then they also, same team also has put an API out there, or a RFC out there, to make the reference interpreter API easier to use and more accessible, so that it can be plugged into very easily, allowing other teams to even add handling for custom calls so that you can make the reference interpreter well tailored to your needs. And then the last one here is a very recent one from NVIDIA, the collective broadcast RFC, which if any teams in here are interested in distribution ops or collectives, broadcast is a way to send a tensor value from one process to all of the other processes in a grid or in a group. But yeah, that one was very, very recently opened. I think NVIDIA has interest in with that specific level of granularity. There's a lot of optimizations that can happen. But feedback for usefulness of this op in other backends as well is very open and welcome. Yeah, that brings us to all of the things that are ongoing in the StableHLO world today, as well as the things that we're planning to be working on in Q4. I guess to get discussion going a little bit, I believe it was your 3 team. You said you were evaluating if StableHLO was a good input format.
Yeah, I mean, our sense is that it is. So the sense is that it is, and we're kind of looking to figure out how we can get started building our own internal proof of concept to see if we can get on board with it. That's kind of where we're at.
Cool. Yeah. Sense is that it is for the sake of well defined, well supported, or I guess what are the metrics of interest?
Well, well supported. We have a lot of interesting problems in terms of how we need to do interpreters and reference models that you guys are thinking about. In terms of getting front end support for frameworks, in terms of portability, everything you just said. So in terms of offset, it also looks fairly compatible to what we have internally at the top level for compiler. So we're thinking it's probably feasible. We just need to like get our hands dirty.
Yeah. Cool. Yeah, that makes sense. Are there any other teams who are evaluating StableHLO similarly?
So what is the criteria for deciding what op is a good op within StableHLO?
To be added to StableHLO?
Yeah.
Yeah.
Collective ops, it makes sense because many frameworks will have, or they will shout the model such that you have collective ops.
Yep.
But something, let's say like a fusion op, I'm not sure any framework will directly produce a fusion op. That is something a compiler might internally produce. So if that be a first class citizen.
Yep. So a few notes. The definition on what makes a good op has changed over the past year and a half that I've been with this team. But generally, if it introduces new semantics that are useful to multiple frameworks or backends, that's an easy win of an op. If it's only useful for a single backend and maybe single producer, we tend to use custom calls for those things. But the minute it's a more generic feature like collective broadcast, there's a torch op, there's ways to do it in JAX, there's similar in TensorFlow, and there's backend support for on several bits of hardware. So this makes this, in my mind, a fairly good op. The question about fusions. That story is still being worked out as part of the extensibility RFC. Our current thinking is if an op can be decomposed into other StableHLO ops, namely it has semantics that are representable by the base set, that it should not live in the base StableHLO op set. But we are trying to provide other ways of capturing those abstractions from frameworks for compilers. So there was an NVIDIA talk earlier that mentioned writing the JAX SDPA library, SDPA API. And the thought there was if as long as you can make sure that what gets emit from JAX to StableHLO is semantically stable, then the compiler, then we can package that in some sort of abstraction. We're calling it a composite in StableHLO. And a compiler won't have to pattern match the internals of it because all you care about is the ops semantics. So it can match that abstraction by name and optimize that way. So I wonder, actually, I might be able to, since this is all public stuff. So what that might look like in StableHLO is, let's say you had a JELU op and you controlled the library for it. This is the proposal for what a StableHLO composite would look like. It has a name, so it's effectively a custom call with a fallback. And so long as this decomposition is stable, it can be generated by JAX or PyTorch or TensorFlow. But as long as the decomposition itself is stable enough for the compiler to only need to look at the name here, my.jelu. This could be, my in this case would be a vendor namespace. So it could be NVIDIA dot or anything else dot. That's the current story for how to express fusions at a higher level.
That's interesting. I'll go through that.
Cool. Okay, yes.
So it's the idea here that if you're writing a backend and you see one of these and you have a fused kernel that you say, oh, my JELU, lower to my kernel. And if you don't know, you use the decomposition and those are just standard ops.
Yep, exactly.
You can do it recursively as well.
So in the design, yes. just because this is just a function that's filled with StableHLO ops, and there's nothing that says that that can't also contain StableHLO.composite ops, because StableHLO.composite is a StableHLO op. In practice, that requires frameworks to permit exporting of these nested things. I see that being very easy on the Jax side. I'm not sure from the other frameworks how that story's been worked out, but if there are requests for that sort of nesting, then I think it's completely feasible.
I think we would request that.
Okay.
That's the sense, yeah.
So from the producer side, how do they generate composite op and for the composite op to have the name, right? How do we guarantee the decomposition of the composite op is the same when the name matches?
Right. So composite op in a way is a custom call with a decomposition attached to it. As such, its definition doesn't live in the StableHLO spec. It is an agreement between the producer composite op and the consumer of the composite op. So in that sense, how do we guarantee that the decomposition hasn't changed? That is up to whoever is involved in that contract of producer and consumer to maintain. The way we've done this for some things internally is we spec the op in a code comment. You could write an adapter around the composite op and then put some verifiers on that adapter. So it says, okay, I expect my composite op to have one input argument, one output argument, and these attributes. And if you write just a simple adapter around them, it's pretty easy to write verifiers to test those sorts of things. Yeah, so it's one goal of composites would be to not have to pattern match the entirety of the body of it, but it's difficult to completely guarantee that difficult to guarantee that it hasn't changed at all without matching it. So that's sort of why it's more on the whoever offered the abstraction to maintain that part of it.
So the producer here has to be the framework, or it could be compiler transform itself.
It would be compiler transform as well. This could just be a way of matching something and packaging it into this op here, which maybe has better handling elsewhere in the compiler pipeline. So there are, I'm aware of some teams who are interested in doing it that way. And then I'm also aware of teams who are interested in doing their own personal abstractions in specific frameworks.
Regarding the collectives, that you mentioned, what is the current, how collectives expressible in HLO at the moment, or what is the proposed change?
For this collective broadcast? Is this what you're referring to? Okay. Gunny, you want to talk a bit about collectives? I think you wrote the spec on a lot of these.
Oh, sorry, could you repeat the question?
The question is sort of more about like what collectives look like in HLO and what's going to be different about this and why NVIDIA is requesting this.
I think in the RFC, NVIDIA is requesting this because it's this type of collective op is widely available in other frameworks. I think that's one of the main reasons for doing that. And another way to kind of do this is to relax the constraints of collective permute that we already have in StableHLO. But I think they've mentioned that it requires some more complex strategy. So just having this as a native op is beneficial in many ways. Yeah.
Okay. Part of my naive questions about some of these things.
No, it was great. And yeah, if you have more questions on these sorts of things, I think this is exactly what goes into the RFC. And then I guess last topic is we've talked actually two brief more topics. On the note of dynamism, we on the StableHLO team are aware of uses for bounded and unbounded dynamism. We're not, at least not yet, the priority of data dependent dynamism hasn't come up too much. So that would be like a non-zeros sort of op, something that looks at the actual values inside of the tensor, and the output value depends on the actual data in it. There haven't been too many use cases that we've come across for that for StableHLO lately. And then we haven't seen too many use cases for unranked dynamism. So in MLIR, that's the asterisk by F32 tensors. That is misaligned with any thoughts in this room, that'd be good to hear. Cool. And then lastly is quantization. The spec we have is uniform quantization. I'm aware that there are other quantization formats out there. There's ongoing discussion for integer quantization with ARM representatives. And I'm just curious if the existing quantization representation here satisfies use cases for quantization. I believe there have been some mentioned already, or if there's something missing.
For LLMs, right, other forms of quantizations seem to be more effective. Smooth quantization. So is this extensibility of those, or is it just fixed?
So I think I'm not the expert on this one. Unfortunately, my colleague that spec'd this out wasn't able to come to the summit today. But the other form that we're aware of is GPTQ quantization, and I don't think that is fully representable in StableHLO today. And the priority of adding that to the spec has been fairly unclear.
There you go, everyone. But also one more shout out to that we will have a ODML breakout session tomorrow in 11 a.m. at least. And if you're interested in running things on device, especially on phones, headphones, glasses, you name it, please check out the ODML breakout session tomorrow.
Oh, see ya. There was some PjRt representation there, right?
I think Aman.
Yeah, I guess I can kick off things here. So thanks, Kevin, for driving the StableHLO discussion. As some of you folks may already know, StableHLO and PjRt go hand in hand. In some sense, StableHLO is the input for the PjRt compile and execute. So with that, we can transition on to a PjRt discussion. Shao, I'm not sure if Sky is in the room.
She's not there.
Okay, so while we wait for kind of Sky to come in, I guess flash the PjRt presentation slides from this morning on the screen, and we were thinking to have an open discussion Q&A around PjRt. So we can do that. If there are any specific questions on sort of what's on our roadmap, we had a slide on that, so I'm going to bring that up here. So first of all, let me just ask, were there any, I guess, open questions on what is PjRt and how it works?
I have no idea about any of those things.
Yeah.
Okay. Shao, did you want to talk about it?
No, I don't want to drag everyone through the mud with me. It's fine.
I'll second that. I would like to know how it works.
Okay, Shao, maybe you can give a brief
Yeah, so
overview.
in a very high level, we will consider PjRt and StableHLO as the API of the open XLA ecosystem. So you can consider StableHLO is the compiler input, right? But PjRt is more like the runtime input. So it provide an integration point for like upper layer framework like TensorFlow, JAX, PyTorch to integrate with the OpenXLA ecosystem. And then if we look into the API specifically, they just only have like very simple method. So like they only have like compile, basically take a StableHLO as an input and generate a device specific binary from it. And then they have the execute method, basically take the generate binary and execute on the device, right? And then there are also a bunch of data transfer methods to like prepare your data for execution, like transfer data from transfer data from host to device, or the other way around, transfer data from device to host, right? And then that is like the very high level of PjRt. This is what it defines. So like it's just like the unified API for the framework to integrate with. But the implementation of this API is everything is up to like the device vendor decide what to do. For example, like for PjRt itself doesn't define what is the binary looks like. So that the binary can be something like, it can be like a very giant device code gen binary you can load directly on the device and execution. This is the model we use for TPU, right? But it can also be like, it can be like a sequence of like kernel launch. This is what we do for the GPU, basically, like, and then also like in the implementation of PjRt, you can define how those binary will execute. Yeah.
One follow-up question that I probably should know the answer to by now. What is a plugin? Does plugin just somebody who implements that API?
Yes.
Okay.
Somebody implement those API and provide the method access.
So, bit of a silly question, like, where do I go to see the actual C++ API that's defined? And is there like a tutorial somewhere of 0 to 1? I sit down, I have a blank folder, and I get to a working plugin.
I think Jamie has some other.
Yeah, so we have the C API header in the OpenXLA repo, and we have a README page. We also have an integration guide. We also have like a CPU example, GPU example, and but there are two ways. One is to implement the C APIs directly. The other way is that we also have a C++ PjRt interfaces. If you implement a C++ PjRt client, then there's some wrapper that we roll. You can directly get a plugin out from your C++ client.
This is in the integration guide too. So yeah, if you can find your way, it's like basically an OpenXLA GitHub repo.
Okay.
XLA. GitHub.com/OpenXLA/XLA.
Okay, I'm an OpenXLA.
ST, and then type in PjRt_C_API .h. That's,
found it.
Yeah, yep. I did this a lot. And
Thanks.
right, so that's the header. And then
Okay.
in that folder, we've put a few markdown files that should help you get started. Like, yeah, and I think the integration guide is probably like where that hopefully is like step-by-step instructions for everything you need. And if it's not, open a pull or feature.
Yeah, and also the CPU and GPU example also in the same folder. They're also unit tests. You can directly run and see.
Jing, is the integration guide updated? It has like the JAX integration too, right?
It has a JAX part integration as well. It was recently updated.
By Jing.
One question. So I'm trying to understand, if you take, let's say, PyTorch Eager running on CUDA device, what is the equivalent of PjRt there? Is that CUDA or what is that?
So it's like PjRt is like a bundle with the OpenXLA ecosystem, right? So like it need to involve like the OpenXLA pilot, right? So basically like to ship your PjRt, there's like a PyTorch/XLA.
It technically doesn't have to involve OpenXLA. Right, but I think, yeah.
Yeah, I think my question is even more basic in the sense like it is not using XLA. So in just the regular PyTorch world running on a CUDA device, I'm trying to figure out where does PjRt fit in.
So like for PyTorch XLA, calls PjRt, like that, it uses that interface. So like it fits in, you know, somewhere inside there when they have to compile, when they have to run things, they use PjRt. PyTorch, not XLA, like vanilla PyTorch, as far as I know, does not use PjRt. So you can only use PjRt plugins with PyTorch XLA. Yeah, in theory, PjRt is compiler agnostic, like it doesn't have to be XLA, like it just has a compile call. And then like you have to pass in a program, and PjRt doesn't really mediate between the caller and the plugin, like what that program looks like. It's just like char star, basically. But that means you still need the plugin and the caller to agree on what the program looks like. It's just PjRt doesn't help you with that. So in practice, I think all the PjRt, both like callers and implementations, the callers being JAX, PyTorch XLA, and TensorFlow, they all sort of assume XLA, you're using XLA or something that looks like XLA, and so they emit StableHLO and send that through the PjRt layer. So yeah, PyTorch, not XLA, like it both doesn't use PjRt, it doesn't use XLA, so it could use either like and or. That's kind of like what PyTorch XLA is. But yeah, it just calls, you know, I don't know how PyTorch internals work, but like, you know, they must call things more directly.
It'd probably be like if there was a layer that just took an FX graph and you didn't know if after that point it was going to convert it to HLO or run it through inductor or something like that.
I think this is maybe, now I'm like really going out on a limb. Part of why like PyTorch XLA was developed to target like TPU, because like kind of native PyTorch wasn't well equipped to do that. Yeah.
So the relevant links are also on the slide decks over here, if you want to follow up it.
What was it? Oh yeah, which I guess will be shared at some point.
Yes.
Go ahead.
So I guess one thing I know we're looking into is GSPMD. And I know we saw on some slides earlier, they were talking about how you can get it through PyTorch XLA. So I guess I'm curious where that fits with the StableHLO boundary. So if we had like a PjRt plugin, how much GSPMD stuff would we get for free versus would we have to re-implement?
Yeah, so PjRt has like close to nothing to do with GSPMD. Is that
right? Yeah, I guess this is maybe more of a StableHLO question.
We combine these sessions.
I'm pretty sure all of that is currently implemented on HLO. Is that right?
I actually don't know.
Okay.
Yeah, so the way I imagine this is that PjRt is a very high level API that, and then the plugin can decide whatever they want, right? They just tell you, okay, today is for the JAX, TensorFlow, PyTorch, XL integration, it just tell you, okay, the input is StableHLO. But like the plugin can decide whether or not to build like a compiler pipeline all by the plugin itself, or reuse whatever component out there is already in the OpenXL ecosystem. And then GSPMD is a component that already is at OpenXL ecosystem. So while you're building the PjRt plugin, you can choose to like, okay, reuse the existing implementation there, then you don't need to build the same thing by yourself. But you can also choose to do everything by yourself.
Do you know if like the GSPMD sharding annotations are part of StableHLO? Do you know?
It is not currently, but we have a open pull request for speccing sharding currently.
Cool. But yeah, I mean, like at least JAX and probably TensorFlow and I think PyTorch XLA, like they already emit the op shardings. That's like they're already GSP enabled. Wait, sorry, I missed the beginning. Are you like a plugin author or?
Yeah, we're from Samba Nova, so we have
great.
a custom chip. And we're
Yeah. Just want to know
we're
what
trying
side of
to
the
plug in.
API you're probably thinking of. I'm Sky, by the way. I work on the JAX team, but also work a lot on PjRt. Yeah, so even though GSPMD, I guess, has no like official compatible, like, API, you could just like, you're gonna get those sharding annotations from Jackson.
Right, so like the stable HLO.
Yeah.
So the stable HLO that we would receive through PjRt would have these annotations in them.
There's somewhere in the HLO, maybe because
Okay.
of the metadata, I'm not sure the details, but like, this definitely works. So they are in there one way or another.
There's a pull request to spec it, right? So once it's spec'd, then the annotations will be there. We can get annotations.
Right, I mean, what this spec basically gives you is that, like, more guarantees about if and how we're going to change things.
Yeah.
Which might be useful,
Yeah.
but like in practice, like opsharding does not. Like, yeah, I think opsharding is like the main GSPMD API. There might be like a few other compile options that are important, but I think it's mostly just opshardings on the chart in the HLO. And in practice, they're like quite stable. I can't remember like a single change to that interface in the last like 5 years.
The specking part of it is currently these annotations are serialized protos.
Oh yeah. So yeah, you have to like know, but yeah, like, so you're going to get those annotations, whether you choose to ignore them or use them, and then you could use them and then honor the API.
And specking and adding into StableHLO would be a more MLR way of accessing the information.
And right, and the GSPMD pass is open source. So it's like, even though it's like not, it's actually like really, I find the opsharding pretty very confusing, but you can look at the implementation since there's not good documentation.
Okay, that's helpful.
This also has to catch up with the collective communication ops that is being worked on, right? Because SPMD would require collective communication.
So there's already a lot of collective communication ops. That RFC was just for broadcast ops specifically. So we already have send, receive, collective commute, things of that nature, yes. Yeah, and one more thing to note is even if the end goal of your backend or plugin isn't to go down to the HLO level, for a lot of things, not all, you're able to go to HLO, run some pass, raise it back to stable HLO.
Okay, that's helpful.
Yeah.
It
is
good insight.
possible, but not guaranteed. The sort of rule of thumb is if it introduces something that is specific to XLA, you can't raise it back up to stable HLO because we try to keep stable HLO as generic as possible.
So I wonder, is there for things like GSPMD or these passes, is there thoughts of basically raising them? So instead of going XLA to XLA, or sorry, going HLO to HLO, they would instead go stable HLO to stable HLO.
There's discussion. It's a lot of rewrite. So yeah.
Is that the direction you're taking though? Like that eventually HLO would be gone and just be stable HLO for most of this stuff?
No, I would not call it the current direction. I think the current direction is stable HLO is the community dialect and HLO is the dialect of the XLA compilation.
Got it. Makes sense.
So given that there are, some folks who are new to PjRt, I think it's also worth reiterating some things from the morning that, while we have the C and C++ API published, and as Jean was mentioned, we also have the CPU and GPU reference implementations available for any plugin authors. We also work closely with, external hardware developers such as Intel, NVIDIA, and Apple, and we have kind of helped. We have collaborated with them to produce plugins which help them execute JAX and potentially have backends for TensorFlow and PyTorch on their specific hardware. So again, we would like to work together with some of you folks here if you want to write PjRt backends for your hardware.
Can you talk a little bit about like the PjRt multi-node API updates?
Yeah. So this was like, we added this as part of converting the existing GPU backend to the PjRt plugin interface. And yeah, basically, like in order, so like PjRt has to play this trick because like each PjRt client is local to a process, which usually corresponds to like one physical machine. But then somehow you have to be able to execute like multi-process computations. And so like this sort of has to magically work through the PjRt API. Like from Jax's perspective or any caller's perspective, it's like you call compile, as long as you get like that same compiled executable on all hosts and call execute, then like it's going to magically run across the entire device topology. And so like on TPU, they talk to each other through ICI, and like the runtime actually has its own bootstrapping mechanisms. Like through TPU environment magic, it can like the distributed runtime can like bring itself up.
Yeah.
Like without any help from PjRt.
Yeah.
Like using external things. And then, but for GPU, we use like Nickel, which is kind of like Nickel handles that like cross-host communication, but you do sort of need to bootstrap Nickel, and we did do that through the PjRt API. This is the C++ API that was like the existing implementation. By like passing, basically Jax spins up a like very tiny distributed system to its own mechanisms, and then like passes RPC handles to the PjRt plugin that expose a distributed key value store, like a slow and stupid one. And so this is enough to just bootstrap Nickel, like with this key value store. And I think this is like a pretty common pattern where you have like a basic distributed key value store that you use to bootstrap a distributed system.
Yeah.
And so, yeah, this new feature, we basically realized like, oh, we didn't have like a mechanism for doing this with the C API, which is like the official plugin API. And that's what this is like basically just adding an explicit, when you call PjRt client create, you get pointers to a distributed key value store. Maybe it's sort of like we think plugin should also handle the case where you don't get that, in which case you might only be able to run in like a single process mode. But it means that callers like only need to pass this if they are running in multiple distributed. Does that make sense?
Yeah.
It's very nuanced. But yeah, this might be useful for like similar mechanisms with other backends. I don't know. Or like in theory, you can use the KV store for whatever you want. But like we're not really making any like performance guarantees or anything, so we don't recommend doing like any heavy lifting.
Yeah, makes sense. Thank you.
Yeah, in general with the PjRt API, we sort of like have this tension between like what should be part of like the generic cross-device or cross-platform API, and like what should sort of be like platform specific magic that you have to negotiate yourself with the caller. So like the program is the thing you compile is like the big example of like, we do not negotiate for that for you. But then there's lots of things like also in the create call, you might have like custom options that are very specific for your hardware. And so like, yeah, those PjRt, it gives you a mechanism for like stuffing them through because that's convenient, but like doesn't have an opinion on what they are. I think this was like an example where we're like, should we just stuff this through and make it specific to GPU? And then like, it's kind of not part of the API, so other plugins can't really depend on it being there, but we decided it's probably like useful enough to make it part of the API. Yeah, so if like, you ever run into things trying to implement your plugin and you're like, something's missing or like this is not quite the right API, like let us know, because it is like just going through GPU kind of opened our eyes to like little details you might not think of.
So one thought from hearing that is it sounds like there's this, so this was specifically with Jax initializing the GPU multi-node environment. Now the JAX CUDA PjRt client that was developed, could you plug that into like the PyTorch XLA PjRt, or like is there additional is the API generic enough you implement it once it'll work with all three users, or are there like specific things that each additional one also assumes about the client, like
In
implicit?
theory, yeah, you should be able to plug it in. I don't know if anyone's tried PyTorch XLA with GPU. I think they like do have a distributed. You tried it, right?
I didn't try it, but I know someone, I work with someone from PyTorch Accelerator to do it.
Oh, that's awesome. Great, yeah, because definitely should work. I think the only reason it wouldn't work is that if yeah, I think in any situation where a caller is like only using one plugin, they might sort of like accidentally not quite honor the API contract in like a way that's okay for that plugin, but not in general. So yeah, I think like it's good that people are trying. But once you get 2 plugins, that's like already probably okay. Yeah, and it'll be great if like we get more implementations. That will also help us like, express and refine the API. Yeah, like I think with this GPU, like TPU is kind of like the de facto first plugin. It's like what drove a lot of this work. And so yeah, like when we like, just like implementing the second plugin, that's when we're like, oh, like there's some stuff we're missing, or maybe some stuff that like only makes sense for TPU. So yeah, like the more experience we get, like we definitely want to hear feedback. Because, you know, we are introducing compatibility guarantees, so that sort of like changes the rate we can make changes, but we like did carefully design those guarantees so we still can make changes so that the API can evolve.
Can you talk more about the compatibility guarantees? What does that entail? Like not breaking the signature or?
Yeah, it's a good question because it's like actually kind of subtle. The thing we're guaranteeing right now is ABI compatibility. So that just means that like JAX, like JAX releases very frequently, and we're sort of starting with JAX, but like this should, in theory, be the same story for PyTorch or TensorFlow. I work on JAX, but so like JAX releases very frequently, and so we expect that JAX will often be like ahead of an installed plugin. So like we were sort of thinking about forwards compatibility where JAX was plugin. So like ABI compatibility basically means, actually it's the same with backwards compatibility, but like we only make like additions to the header file in such a way that like JAX can load a plugin built at a different version of the header file and like still be able to successfully run functions and not like seg fault or like call the wrong function or something. So this is like the very most basic level. It's like necessary for any kinds of compatibility. And we are guaranteeing with JAX 6 weeks of forwards compatibility. We're sort of using a time-based schedule instead of a release-based schedule because JAX is, like, doesn't have a release schedule. But basically, like, you have 6 weeks to update your plugin with any new features we add before JAX starts like assuming that that new feature is there. And in some cases, that can mean just like returning unimplemented. But just like for like ABI compatibility, it's like, you know, PjRt is sort of structured, you have like these function pointers. It's like that function pointer should point to something and not random memory. Because then like, yeah. So you have 6 weeks to just like, and this means like making a release. We probably will extend this to longer to 6 weeks in the future. We just wanted to sort of like start conservatively while we, just to make sure that like we actually can guarantee this and get everyone used to the forwards compatibility practices before like guaranteeing a lot, but then accidentally screwing it up or something. So that's what we're working on right now. Or like what we're like very close to guaranteeing. Beyond that, that's just like that like JAX can like load the plugin and call functions without like seg faulting. There's also this question of like, okay, what features like actually need to be implemented to have a good experience with JAX or any other given framework. For example, like you better implement compile. Like no one's gonna have a good time if you don't implement compile. There's some other features like like host callbacks, which is like only implemented on TPU. But like it's sort of this more advanced feature that powers some of Jax's debugging APIs that let you like print values and stuff from compiled computations by like having your compiled device function like call back into the host. You could probably get away without implementing that. Like Jax's debugging features won't work, but like users can maybe live without that. So there's like sort of these different levels of like how necessary something is. We haven't really spec'd that out yet, but we do want to make it more clear like what is necessary versus like what is a nice to have versus what is like maybe no one needs this except for like one platform. And then the other thing we're working on is experimental features, because like we sort of need a way to like introduce new features but then be able to iterate on them quickly. Like it's hard to land the right API exactly right 100% of the time. So that's like, you know, but and then like the contract with that will be like, okay, like Jax will call these experimental features if they're there, but then like we won't depend on them. So like as plugin authors, you can either like implement the experimental features if you really want to be in the bleeding edge, but you might have to update them more frequently than the forwards compatibility window dictates. Or you can just be like, I'm going to wait till this settles down before touching it. But we want to like clearly demarcate that. I think that's all I have to say about compatibility. Jay, do you have anything?
Oh, no. Only thing just like the plugin would define the behavior when the plugin is newer than the.
Oh, yeah. Oh, sure.
So all we talk about is like the framework newer than the plugin. That's okay.
So, basic question. Compatibility guarantees of StableHLO and PjRt are completely independent, right?
Yeah.
Like PjRt doesn't care. It doesn't even care that it's a StableHLO program, really. Okay.
Right. There was discussion about allowing plugins a way to query, like to discuss their capabilities with the producer. So you can figure out if a StableHLO input would be compatible or not. I don't know if that's been fully designed yet.
Okay.
And I guess the other part about compatibility is that plugin authors, you are in control of your own backwards compatibility policy. So that's like if you want to release before Jax does and have the plugin work, like that's up to you. Probably a nice thing for users, but like you don't control that.
Sorry, Nate. I'm asking stupid question, forgive me. So, I see there's an NVIDIA plugin available. Do you have idea when like AMD or Intel plugin for the GPU possibly available? Intel's already available. Intel is already available. Oh, okay. Related, I'm not sure it's right question about it is performance monitor part of considered in this plugin?
Great question.
No, I'm saying in terms of do you kind of plan to monitor the performance and to give feedback to tuning or auto tuning or to cogen regeneration?
No, we like I hope that can actually happen like underneath the plugin boundary. Like so, as a plugin author, you can like implement that if you want, but yeah.
Cannot be one-time compile, right? Because
Well, you can compile under the hood if you want. But yeah, Jax itself will basically only call compile once.
It's like compile.
Yeah, Jax, at least, and maybe other frameworks are different, but like, yeah, I don't think anyone has something where they'll like automatically recompile.
This is basically.
so you're saying you do have maybe something in this plugin might collect performance stuff.
I think that like the API doesn't really have anything about that, but you can do that like below the API then. Like I know, you know, like I think the XLA GPU does like
Yeah, the Excel
performance tuning during the compile call. Like they actually run things. So like it does support that. But like yeah, I think the interface is high enough level that hopefully you have like a lot of leeway to do your own monitoring. And if
by all means not in this side.
like as a plugin author, like as an implementer of the API.
And then we also have within Google, we also have some like feedback directed optimization. So basically like on the TPU side, we would have like, oh, we may generate a different profile, and then based on the profile, we may tweak like the compilation option a little bit to have like better performance, right?
Oh,
But
that's true.
yeah, but this is fully like orthogonal to the PjRt API stuff. It's like something at higher level. So basically, inside Google, we have a service assistant. Okay, when you every time you compile execute, you can like produce like those compile data to this service. And then at some time, like okay, when we want to like trigger some compilation, it's also like we will start the job and then it will trigger.
You mean the TPU combination?
Yes. So everything is like orthogonal to the PjRt kind of stuff.
Yeah, like that TPU thing is like from PjRT's perspective, it's just a compile option.
Right.
That's like, yeah, like there's this like other service that's like doing monitoring and like it just sets this compile option and then like that plugs it into the implementation. You should sorry, I assume you're like interested in authoring function. But like if there's something missing from the API, like email us or like post an issue on GitHub because
because
we might be missing something.
I encounter some issue like normally people publish in PowerPoint, they just do benchmarking on specific input, specific setup, specific model size. But once I deploy it, sometimes I really suffer from no performance, so I don't want the engineer to redo. It's long time, right? Turn back times, right? Something can be built for the system to automatically send what and then regenerate the bytecode will be perfect.
Yeah, I mean, that's kind of PjRt, yeah, is above that. Like that's up to the platform to implement. You're just giving an interface for like JAX to use that platform or PyTorch or TensorFlow to use that platform.
To support that, you may also need to do some similar system. So you can collect the profile and then generate the compilation option and feed it back to the PjRt and order.
I think we should probably call it there before they start worrying about us.
Yes.
Feel free to find any of us at this after hours event we're about to walk you all to.
Thank you. Yeah, thank you.
Yeah, so
Awesome.
basically,